In the previous tutorials, we've specified the model for linking data contained in the Fake 1000 dataset. It's now time to have a go at predicting the links from this model that we've specified. This is done using the linker.predict function. This is a relatively easy task to complete once we've specified the model. So the linker.predict function will create a list of pairwise comparison that match at least one of the blocking rules. It will evaluate the potential for those links as specified by the comparisons that we've laid out, and it will use the estimated match weights to produce the final match weight and the probability scores for each of these. In addition to predicting the model, there's an alternate representation that the list of potential links can be given as, and that is by means of clustering. So, for example, if you have units with a unique ID, in this particular clustering we see that units 23, 37 and 40 fall in one cluster, potential links, and units 12 and 18 fall in this second cluster, and potential links. The code that we use to do the predictions is relatively simple, and it's just a matter of applying this one predict function. So initially what we will do is we will import from Splink this linker function, the DuckDB API and Splink datasets, and we will specify the Fake 1000 again to be df, the data frame. Now we just need to load the model specifications which are contained in the file settings that we previously saved. So use this command open and the path to the file that you want to link, and we will call it settings. And finally we will define linker to be equal to this function linker, which takes the data frame, the Fake 1000, which takes the model specifications as defined in settings, and says that we will use the DuckDB API to do all our SQL work. We run this code. So now we have everything set up. So all you really need then to do these predictions is your data set, the model specifications, and which backend that you're going to be using. With everything in place, it's a simple matter to run the actual predictions. So we're going to set the data frame underscore predictions to be this linker that we've defined above, and we're going to set this threshold match probability equals to 0.2. So we will discard any potential links with a lower than 0.2 threshold match probability. And then we'll output these predictions, just the first 5, using pandas. So we will run this. And here we see the output. So the time it took and this warning. You'll remember that there was one of the comparison levels wasn't fulfilled using email. So this warning simply says that there was default values used for the M probabilities for one of the email comparison levels. And underneath we have the output of these potential links. You can have a quick examination of what these potential links look like. You get the match weight, the match probability, the unique identifier on the left and right, the first name on the left and right. So we see that the unique identified unit 110 and 112, well, they had identical first names, Oliver. And then we had this term frequency adjustment on the name, 0.033, etc. And all the other aspects of the match. So they didn't have identical surnames, Atkinos and Atkinson. So there was probably some spelling error, but it probably came through the Jarrow-Winkler comparison levels. They're both from London. Date of birth 2009, 21st of the 12th, 2010, 20th of the 1st. So this is the output that comes from this predict function. As we mentioned previously, there's an alternate way for examining this data set here, and that's instead of having every single link spelled out one by one, is that we cluster them together. So we use this command here, cluster pairwise predictions with the threshold. We're setting the threshold match probability to be 0.5, and we're going to output the first 10 of these. And here we have the output. So there's a new cluster ID. So in cluster ID 0, there's just one unique ID 0. In cluster ID 1, there are 2 unique IDs, etc. That's simply all there is to predicting the model, given the model specifications. The next tutorial will have a look at far more intuitive graphical output of how we can examine these predictions that the model gives us.